Good afternoon. Welcome to course Thermodynamics of Materials. Today we are into lecture 117 and 118, and we are continuing with solution thermodynamics as before, and we are discussing alternative standard states on Henrian 1 mole fraction standard state and Henrian 1 weight percent standard state. So today we have discussed. Last day we discussed one mole fraction standard state, and today we also will consider Henrian 1 weight percent standard state. Henrian 1 weight percent standard state. Henrian 1 weight percent standard state. Okay. This will and we will also correlate the results we obtain with the consideration of Henrian 1 weight percent standard state with those obtained from Henrian mole fraction standard state. And also we will have three standard states. One is Raoultian standard state. You may call it classical, or say we have so far used Raoultian standard state. Then another is Henrian Henrian 1 mole fraction standard state. Henrian 1 mole fraction standard state. What is the Raoultian standard state? These are. And this is Henrian mole fraction standard state. This we have discussed relationship, and this is today I give you quickly what is going to come. This is Henrian 1 weight percent standard state. This point H weight percent. This point, exactly this point. I given an arrow 1 weight percent. N is here. This is here. This is there. N is there, up to which Henry's law is applicable. So that linear part. This is within the linear domain. In the linear domain, where Henrian weight percent. So this is new. Still another alternative. One already Henrian mole fraction. Today Henrian 1 weight percent standard state. We'll actually move on with this activity. This figure will refer. The same figure will refer, figure 1, for this discussion. Start. So as I told you, Henrian I'll explain these points. These points as I go on. These points I will explain. And what else? Okay, these points, and well, this point particularly this one I will explain, and this scale I will explain also. This scale, HB8% scale. And okay, very good. Henrian 1 weight percent standard state. Sometimes we actually say Henrian weight percent standard state. That's one we do not mention, but it is implied. 1 weight percent. Okay, is located at point. Which point? See, as I told you, H weight percent. This is the point. just not H. I have to give a subscript just to distinguish this H from the H of mole fraction. HMF, HMF, and this is H weight percent. MM means mole fraction. So H, this is the point, this is the state. So this is 1 weight percent standard state is H weight percent is H weight percent is point at point H on Henry's law line, on Henry's law line. On Henry's law line, which is line ON. See here, what is the Henry's law line? See here, O, last recall, O, this is the O, this is O, O, these are 0, the scale 0, XB scale 0, and gamma B activity B 0, this is 0, 0, this is O, O, N, HM. The extrapolation of ON up to XB is 1 last step and gives rise to the Henrian 1 mole fraction standard state at HMF. Today, H weight percent. This, as I told you, on Henry's line, what is the line? You may call this Henry's line ON. You may call it ON HMF in figure 1. In figure 1. Very good. Now, this is the given. Now, as before, our aim would be, see, this is our aim, I tell you. This is our aim, to describe the equation of Henry's law line. When I say Henry's law line means it is ON maybe, or ON HB, I'm sorry, ON HMF, the same line, or now actually I have introduced H weight percent on that line. So H weight percent in HMF, this line, okay, same line. So as before, what I want to do, to find the equation of this line, which I say, which we call it is Henry's law line. This line ON HMF line, the equation in terms of new standard state, HB weight percent, that we mention, that we write soon. Okay, so 2 we have already done. What is the equation of this line in terms of Raoultian standard state? Your answer is AB is gamma B0 XB. AB is Raoultian activity. I told you symbol A for Raoultian activity, and symbol A will not apply for Henry standard state. Activity in terms of Henry standard state with reference to Henry standard state, no. What is the symbol? H. HBMF for Henrian mole fraction standard state. What was the equation? The same line was represented as HBMF is XB. And today we find what the equation is of the same line in terms of HB weight percent, the new standard state. This is the job. This will, when we will finish this part. Let us see. So, now, like last time, as we did in case of the derivation of this one, HB mole fraction is XB, the same approach will take. It will be slightly complicated because of the weight percent conversion of XB into weight percent, etc. As you soon see, as before, we are to find the equation for the Henry's law line or the Henry's law line. What is the law line? Again, I am repeating this. That is line ON HMF. That is O H weight percent N MF N HMF. Same line. Okay, H weight percent is placed on the Henry's law line on ON. Is placed on the ON or its extrapolation. I tell you beforehand. Maybe at the end I will actually mention this. But today I tell you. See, N is where? Follow N is here. Up to which the linear behavior holds. That is Henry's law. So Henry's law actually ON. This is the extrapolation of the Henry's law line. ON is the really truly speaking ON. ON is the Henry's law line. And 1 weight % B is at a concentration less than that of N. So here. So it is interposed as if H weight % is interposed between O and N. So ON, the linear segment, within the linear segment. But I tell you, this is often found in textbooks, okay? But I tell you, there is no harm if ON, this domain of Henry's line, which is actually not large, small actually. So it may be possible it will not cover 1 weight %. N does not cover 1 weight %. Means N corresponds to a concentration less than 1 weight %, say 0.7. Then where you place this standard state, 1 weight % being new standard state, where beyond N, but at the same time on the extrapolation. So beyond N, so linear segment ON, N may be here. I show you here maybe. This is ON. So follow ON. Now this is 1 weight % B. This point is known as H weight %. This point. This is a Henrian standard state. Place. Very important. Where is the standard state? Which state is the standard state? Henrian standard state. But if it happens, this is, so this looks like this is N, concentration of N is greater than 1 weight %. So follow this. This time I have shown here. But it may, and this is the extrapolation. To where? Up to HMF. This is another standard. This is the first alternative. So now in maybe there is no compulsion about having this point, this 1 weight % before N. So maybe it's no compulsion that its concentration would be less than that of N, or conversely, N concentration of N, that is the linear segment limit. That is the limit. Linear limit. Then after this, what has happened? This has broken into curve. So doesn't have to be within ON. So if the concentration of N is less than 1 weight %, suppose I tell you what, it may be possible N is, in the second case I am showing second case. Sorry, very sorry. ON. Now I am extrapolating it to what? HMF again. And this, after this linear part, which is Henry's law, then this is curve. No more linear. So this is Henry's domain. At 1 weight %, it is actually less than. Suppose less than weight %. Say 0.5 weight %. Then where is the 1 weight %? This Henrian standard state will be here. This will be 1 weight %. And this will be named as H weight %. this point, this like this point. No harm, no harm. But it is on the extrapolation of Henry's law line, on the extent of Henry's law. Henry's law is this much. Henry's law is just this much, and in concentration is less than 1 weight percent. Then this should be beyond n 1 weight percent. Here it was the way I have drawn. It is within n means before n, smaller than n. This is larger than, greater than n. No problem. But no, this will work also. Exactly the same. No problem. But sometimes there is a mental block, I would say. Mental block. People love to show this within the Henry's law domain. But it is actually no problem. It is extrapolation is as good as. So no problem. Actually, these are all actually hypothetical standard state. So if it is there, no problem. Mathematically everything is okay. The operation of this applications and use of these equations of this standard state will remain same. Of this standard state will be as good as this. The relationship will be exactly same. This I will show. So I will actually gradually go to the different relationship that we get. So this is one mental block I am trying to remove. Okay. Often you will see in the book it is as I told you. So let us move on. So what is this? We have to find this is the requirement. We have to find. I will get this. Okay. Okay. We will further go in terms of the equation in terms of, as I told you, in terms of Henrian weight percent, Henrian 1 weight percent standard state. Remember, this is the job today. That is this equation actually. HB is weight percent approximately. Exactly I will give you. Exactly precise I will give you. And approximately also I will give you. And why approximately is important, that here I have written for some reason, one reason that there is no space mark. Okay, much space. So small form I have written. But this is also very useful also. This approximation is also useful. This I will explain. Okay. But so what is happening? So we are going to find this equation for the same line, Henry's law line. Henry's law line as if starting from O up to HML. This is Henrian standard state, means HB weight percent. In terms of HB weight percent, I repeat, in terms of AB, Raoultian activity known. And what is that? That is very much known. Activity of B is gamma B0 XP already. And in terms of first alternative HB mole fraction, the equation is known. HB mole fraction is XB. And today it is HB weight percent is what? In terms of as function of weight percent be what? That we will see. Okay. So this is the job in terms of Henrian weight percent standard state. We already have the equation for ON HMM means Henry's law line. In terms of Raoultian standard state, in terms of RSS means Raoultian standard state. Last day it was done. And what is this equation? Can you tell me? As what? Tell me. AB Raoultian standard state means A. Activity A is the symbol. AB is, tell me what? Gamma B XP. AB is gamma B XP. Now, since we are dealing with weight percent, convert XB in terms of weight percent. And what it will be? It will be gamma B atomic weight of A, weight percent B by atomic weight of A, weight percent B plus weight of B, atomic weight of B times weight percent A. This is a conversion. Why? Using the conversion, recall, is using the conversion, interconversion of xb and weight percent b. Recall, first class solution thermodynamics, first class. What is this given? To get this xb is, recall, tell me, weight percent b divided by atomic weight of b, divided by weight percent b by atomic weight of b plus weight percent a over atomic weight of a. You do this, you see, it will get this. Okay, no problem. Okay, very good. So this is the conversion, interconversion. Shall I give a name to this equation? Of course, I shall give gamma b0 xb. Oh, I made a mistake. We have already got the equation of ONF in terms of AB is gamma b xb. This linear segment and extrapolated to here, that is Henry's line. What is the equation? Here, as you see, AB is gamma b0 xb. Very important, very important. AB is gamma b xb represents this curve also. This curve generally is AB is gamma b xb, and this takes this shape. AB is gamma b0 xb in the linear portion, that is Henry's law portion, in the dilute concentration of solute B. In dilute concentration, this is okay. This is very good. AB is gamma b0 xb. So call it equation 1. This already we know. We go by the equation numbers. Okay, sequentially 1, and today we get it as here. Equation 9. Equation 9. Equation 9. 8 last class. Last equation number 8. So today is 9, and this 1 is already known. 1 is already known. Okay, very good, very good. So 9. Now exactly same procedure as with Henrian mole fraction standard state that we have covered last class. Quickly, now establish the relation between the two standard states, namely, what is this two standard state? Raoultian standard state, which is RSS, Raoultian standard state, and Henrian weight percent. Weight percent means 1 weight percent. Henrian weight percent standard state. This is in short. This is in symbol. Symbol means short form HSS weight percent. Between this, okay, HSS weight percent. This is, let's establish the relation between these two. What? Let us begin with as before with the equality to standard state. When you want to relate, that this is the okay procedure. Equality is what? Remember, GB bar is this equality. GB bar is GB bar. GB bar is GB bar, or GB0 GI bar is, recall GI bar. I will recall this. Recall here. GI bar is GI0 plus RT ln AI. Activity of this state relative to this state. I am often talking of this, repeatedly saying this. This activity with respect to this standard state of which state? This state. This is a non-standard state as if. This previous the same apply. So this relation you apply here GB0, GB0, and what type of GB0 you call it? You consider these two. So this side you consider Raoultian standard state plus RT ln what you write? Activity. You write activity of B with respect to Raoultian standard state. The left hand side equals to right hand side is similarly, is GB0 again. Now you are choosing here SS 8%. Then you write similarly RT this. Change standard state. This activity will be with respect to that change standard state. You change here, you change there. Suppose it is solid standard state initially, then you change the activities with respect to solid. You change it to liquid, change it different. Then this is unchanged. Then this difference will give rise to activity with respect to the new standard state, namely liquid. Here, one is Raoultian, another is Henrian. So, but principle remains same. So, choice of standard state is very important. No, we say choice of standard state is actually you can is arbitrary and matter of standard and matter of convenience. Arbitrary and matter of convenience. So anyway, let us see. We move on with this plus RT ln. Write this. Exactly write this ln activity. Why I am writing activity? I like to soon put the symbol. Next slide. I am trying to show you. Call it activity, but what symbol? It depends on what reference, what standard state it is referring to. Activity of B, tell me, with respect to Henrian standard state 8%. Very easy, very easy. So here this activity with respect to the same standard state as this. This activity with respect to the same standard state as this. Clear? Yeah. Activity with respect to this standard state. This is the meaning. So I am actually writing with the. I have started with the equality. So two sides on the either side I can use any chosen standard state. I have chosen here left hand side is Raoultian standard state and the right hand side I have chosen Henrian 8% standard state. Since this is actually our topic today, so I am removing this. This is not needed. You have understood quickly. Or GB0 RSS plus RTLN. What this symbol you know? A for activity of with respect to Raoultian. So RTLN. So easy. AB is GB0 HSS 8% plus RTLN. And what is the symbol? Since Henrian standard state, what it will be? Activity of B means HB, and it is 8%. Previously it was mole fraction. If it with respect to Raoultian standard state mole fraction, but this is Raoultian standard state 8% HB. Both are HB. But this is HB 8%, and previously it was HB mole fraction. For example, here the scale you see HB 8%, HB mole. This scale HB mole fraction, this is HB 8%. That I will explain. Today I have not shown it here. Okay, but this was last day I showed you HB mole fraction. This is what? This is Raoultian activity. Symbol AB. This can Raoultian. 0 here, 1 there, and gamma B is fraction. Okay, very good, very good, very good. Okay, so or right here, why the symbol? Specify that symbol. This is note AB is the, which you already know. Note AB is the okay. HB is what? Is okay. Note AB is the what I say. Note AB is the symbol for Raoultian activity. Actually, it is a symbol of activity of B at any state, say at any state, say state P. State P here, P, just any arbitrary point on the deviation from Raoult's law, this card. So AB is the symbol that I use. AB is the symbol of the activity of B at any state. So activity of B must be at a state. Two things remember. These are both are activities. Raoultian activity is activity. Henrian activity is activity. So AB is the symbol of activity of B at activity. Clear? AB is what? Symbol of what is activity of B with respect to activity of B. Activity of B where? At a certain state. What is the state? State is P. And B is the component. So activity of B at this state called P. That P you have actual composition at the P means certain composition. State is given by the composition and temperature pressure also. So say state P at any state, say state P with respect to at any state of is the activity of B at activity of B at any state of B given by the point P with respect to Raoultian standard state. As mentioned, this was already mentioned. As mentioned before, in the last class it was mentioned, but I have to repeat this because I will explain this symbol, so I should repeat what this symbol is. That's why. Okay, as mentioned before, and HB this one HB weight % likewise, right, is the symbol of activity of B. Just exactly paraphrase activity of B. Repeat B at any state, wherever state of B at any with respect to now Henrian weight % standard state with respect to Henrian Henrian standard state or note this. This you noted before. Today you note this HB. This is a symbol, and I have written with respect to Henrian standard state weight percent means 1 weight%. This I am not writing, okay, unnecessary. Is implied. Is understood, very easily understood. The standard state are clearly shown. Standard state, 3 standard state clearly. This is first Raoultian. This is the this point. State is a point. Second, HMF, the point named HMF right here, corresponding to XB is 1. Extrapolation of Henry's law line, linear segment extrapolation. Second, third is this, at 1 weight% B on the same line. Name point, that state of that point is H weight%. So 1, 2, 3, 3 points, 3 standard states. And we are dealing with them. Let us see. And they will be extremely important for our, for actually, for chemical metallurgy problem solving. For solving chemical metallurgy problem, particularly iron making and steel making. Particularly steel making. Okay. Go ahead. Let us see. What is this? Or continue here. Or continue from this. Or RTLN, activity of B is what? Right? GB0, HSS, weight% minus, take this to the other side, minus G0 RSS, your bracket, and put a third bracket or square bracket here, plus RT ln HB weight%. Okay, this is okay. So this is. Have I changed the okay? See, I will give a equation name here. Up to what we have 1, 9. This is 9. This is 9. This is 9. So this will be this one 10. Call this equation 10. Call this equation 10. Okay. No, sorry, not this. The earlier one. This one. This is equation 10. Equation 10. Not this. Not that. This is actual side change. This is transposed to this side only. This equation 10. 10 is the main equation. Okay. Next, or RT ln AB is, what is this value? This is interesting. What is this? And what I taught you, how to get this? Always use the relation. Remember, GI, never forget GI bar minus GI0 is RT ln AI. So what is, this is, say, suppose GI0, then anything, maybe Henrian standard state, don't worry. Anything other than this is called this GI bar. It plays the same role as GI bar. This is this GI bar minus GI0. Suppose Raoultian standard state, this one in GI0. So the result is RT ln AI. I told you what clearly, AI of this state relative to this state. This state incidentally Raoultian standard state. So, and this state is incidentally Henrian standard state weight%. So what is the, what comes out from this, what emerges from this, that this is nothing but RT, keep on writing, RT ln AI, activity of this gentleman with respect to this, that you write, activity of, writing spelling, okay, spell it, activity of, I hope activity of B at HSS weight percent. You understand? Point. Okay? This point, HSS weight percent. This point. This activity of this with respect to referred to RSS. This part plus RT ln HB weight percent. Take a look. I am removing this. This is very helpful to understand this. See, like it is GI bar. This is GI 0. This is not 0, but this is 0. Still, this is 0. Anything other than this will be treated other than this, anything else will be treated as GI bar with respect to this. Everything is GI bar to it. So GI bar minus GI 0. And result is, apply the result, is RT ln activity of this, means activity of this state. What is the name of this state? HSS weight percent. That I have written, activity of B at HSS weight percent. Related to, what is this? Of this state, related to this, relative to here, relative to of this state, relative to RSS. Raoultian activity means A symbol. AB, simply what is this? AB at this. What is the value of AB at this state? AB of this state, at this state. This actually comes out from this. So I remove this, remember, and I will actually now go to the top, okay? So I am removing this. You understand? Remove this, all this. Even I am removing solution thermodynamics to make room, because actually this space is occupied by this figure 1 and this relationship. Actually, one thing I want to write here, XB, where I write, I want to save this. I don't think it is written here anywhere. Okay? No, this is not written here. No, XB is this relation, right somewhere. XB is maybe helpful. XB is what? Interconversion XB and weight percent B. Tell me, and result is this: atomic weight percent B over atomic weight of A, weight percent B plus atomic weight of B, weight percent A. Weight percent A. This you say. This relation very interesting and very important in this in the coming relations and coming actually steps. Okay, we'll see. So remember, M is already I have given, so I have removed this. M, you know, find the equation of this line in terms of HB weight percent. This is almost we are there. So please remove this. This is good enough. I have saved what I have saved. The figure 1 I have saved, and these 3 equations and these 3 equations I have saved. And now still another equation. And go ahead. So you move on, or you write RT ln activity B. Give a star here and give a star there also. Give a star there also. Here RT ln activity B. What is this value now? Tell me. What is the activity of B at HSS weight percent, means this one. Activity of B at what I have written here, activity of B at HSS weight percent. Instead of writing HSS weight percent, of course, this is what? H weight. The state is what? Activity of B at H weight percent. Activity of this means activity of this with respect to this. This means this is actually Henrian weight percent standard set, is H weight percent. At the point, activity of B at this point, activity of B at H weight percent, easy, with respect to Raoultian standard state. Okay. Now, take up this. What is the activity of this? This, what is this value? Then you are all set. What is this value? RTL and activity I have written there. So, what is the activity of B at this state? What is the activity of B at this state? Activity means AB, rather AB. When with respect to Raoultian means AB. With respect to Raoultian means symbol AB. AB is what? What is this value? Like this. What is this value? What is this value? How do you get this? What is this? This state is on the line. Which line? Which line? AB is gamma B0 XB. What is the equation of the line? AB is gamma B0 XB. So you write here. I am writing here RT ln. I am writing in gamma B0 atomic weight of A by atomic weight of A plus 99 atomic weight of B. Happy? This and this is this much, this much, this much. This is this. This is this. Plus RTL and HB weight percent. Plus RTL and HB weight percent. Now you are entitled to ask how you get this. Let us see proof. I am writing here. Proof. Okay. Okay. Proof. What is the proof? Proof is this. Note. Proof is here. Note. So note is activity of B is what? What you have? Activity of B. Start. Activity of B of this state with respect to Raoultian. So I am saying AB. What is the AB here? Here. And what is the line? What is the equation of this line? AB is gamma B0 XB. So write AB is gamma B0 XB. But this time you have to qualify it. For what? XB corresponding to 1 weight percent. That's it. Now what it is gamma B0, right? What is XB? I have saved this. Write this out. Atomic weight A, weight percent B, atomic weight of A, weight percent B plus atomic weight B, weight percent A. Happy? Okay, good. And write in bracket, this is the general XB, but this XB at 1 weight percent B. So tag 1 weight percent B. Now what it becomes? You clearly see gamma B0, weight percent B is 1, substitute atomic weight of A only, top, numerator. And weight percent B is 1. So what remains? Atomic weight of A. And weight percent A is how much then? If weight percent B is 1, weight percent A is 99%. So 99 atomic weight B. Just you save this. So this is the reason why I have written this. This is the reason. This for this what I have written. This I have written. See, gamma B ln gamma B0 atomic weight of A, atomic weight of A plus 99 atomic weight of B. These I have copied here. Okay, this is the explanation. So this is actually explanation. Okay, so don't be. I don't have space, so I am just encircling this part. That's addition. So explanation of this term. Explanation here. Now let us move on. Move on. Remove this. Oh, sorry. I don't want to disturb figure 1. Very important. Very important. This figure. Pure B. I don't want to disturb at all. Raoultian. I am very sorry that I actually damaged it. Never ever. Okay, save this and this equation. So 7 equation, 3 equation, 3, 6 plus 1, 7 perhaps so far, and this figure. So can I remove this now? This remove, we don't need anymore. You only maintain the sequence of the equation. So far 9, 10 we have got, 10 and what else? 10, yes, very good, 10. So far 10. Good enough. Or you continue, or from here, or will you write? Achha. Will you do one thing? Can you cancel RT? So what you have? ln AB, left hand side, is what? ln well, ln AB is ln, right? ln gamma B0, right? That as you see, atomic weight of A plus 99 atomic weight B plus what? RT cancel ln HB weight percent. So one equation I have removed. This is actually okay, very good. Or AB is right ln how much time? Okay. AB is what? Tell me. AB is what? Tell me. Gamma B0. Sorry. AB is what? Gamma B0 times atomic weight of A over atomic weight of A plus 99 atomic weight of B. ln sum means product. HB weight percent. I'm sorry, this actually I have to get some space here. HB weight percentage. Weight percent. Okay. Okay. HB weight percent. Very good. So this is very important. Why? This relates. Call this equation what? What is the last one? I told you what? 11 perhaps. Call this equation 1, 11. Okay. Okay. See, this actually gives the relation between AB and HB weight percent. AB and HB weight percent. Now, so move on. Comparing nine and 11. What was the 9? Actually, I have removed that. What was the 9? Equation 9 was, recall. What was the equation 9? I have removed this. Equation 9, if you check this, how equation 9 is here? Equation 9 is where? 9 was, just to help you, equation 9, just to help you, what was that? 9 was, activity of B is gamma B0, atomic weight percent B plus atomic weight of this equation 9. Oh, 9, I could have obtained from here. No, 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 no. 9, no, I will not get this from here. Okay, anyway, this. So if you compare this, what you will get? AB left hand side same. So you can write this gamma B0 atomic weight of A over atomic weight of A plus 99 atomic weight of B times HB weight percent. Clearly see, HB weight percent. HB weight percent. This is left hand. This is the right hand side of AB. This is the right hand side of AB. Is what? Equate this gamma B0 atomic weight percent B by atomic weight percent B, since you don't have much space, plus atomic weight of B weight percent A. This plus. This is plus. Yeah, this one 9 plus. Okay, this or what you gamma B0 cancel. Atomic weight A cancel. Or you have what the desired equation coming. HB weight percent is what? Follow this. Atomic weight A, this goes to the other side, plus 99 atomic weight B. Okay, this goes to the other side. What you have? By atomic weight of A weight percent B plus atomic weight B weight percent A. So this goes there, this comes there, weight percent B still remains. Percent B, weight percent B. This will be your, this is actually your equation number what? So far what equation number? 11 you have already given. HB weight percent. You have given 11. So comparing this 12. This is the 12. Incidentally, this is written here. See, 12. See, I have saved this. So don't worry. I have saved here equation 12. Equation 12 here. Okay. So I am just enlisting this now. So you write this. So this is our desired goal. What is the goal? The equation of the line ONHMF, and this is the line in terms of HB weight percent. In terms of HB weight percent, you see, this is the precise relation. Okay, exact relation. This is approximated to weight percent B, only weight percent B I have written here. For reasons I will explain. So you remove this, But anyways, this 12 actually I have already saved here. So you, one thing do, I tell you what, this is the, then tell me, this is the required, which at the start we said this is the required equation for O OH weight%. You may call OH weight% or same line, or that is ON or still or ONHMF, all same ONHMF, or still or you include all points O, next H weight%, next point N, still next point HMF, MF. Okay. So 1, 2, 3 equations from the Henrian line. 3. This is the third. Second, first, second, yesterday we have covered. This third. These I have actually collected together. Okay, listed together. 1, 1, 1. So these I am writing, but I will save time because it is already written. So we have three alternative you know what is alternative equations? Alternative equations for the Henry's law line. For the Henry's law line, or its extrapolation, you may call it Henry's law, valid up to this ON, but extrapolation or same line. Henry's law line, that is what I have written here. OH weight%. Again, I have written, repeatedly written OH 8%, so that you don't have any confusion. Okay, so no confusion. Or ON or ONHMF. So you remove this. What is this? 3. These 3. So we have 3 alternative equations for the Henry's law line. See here, 3 alternative equations for Henry's law line. 1, 2, 3. And equation numbers also you can check this. This equation number is 12. Last one 12. And others are equation 1. I have already showed you somewhere. Equation 1. Okay, this one and this 4. This is 3. So very easy. Quickly, how will you get this? Quickly, what is the equation of Henry's law line in terms of Raoultian activity AB is gamma B0 XP. What is the equation of the same line, Henry's law line, in terms of Henrian mole fraction activity is in terms of HB mole fraction. In terms of HB mole fraction is simply is mole fraction B, is simply is mole fraction B. Okay, and what is the in terms of weight% B? I would say this is the equation. This is the equation. Yeah, clear. Right here, clear. See, HB weight% is this factor, atomic weight A plus 99 atomic weight B divided by atomic weight A, weight% B plus atomic weight B, weight% A times weight%. So this is H. This is XB, right hand side XB, and here right hand side weight% B with this coupled with this factor. Okay, this factor. Now about this factor, I will add it in an important word. How this can be approximated, and that approximation I have used here. HBMF is approximately weight%. So follow this here. Okay. Now note important. So this is already I have shown already. See, so here. These three. Okay, I'm showing you. These three. So next is what I am trying to note. For dilute solutions, and Henry's law obey for dilute solution. Small concentration of solute. For dilute solution, Henry's law obeys all as I have explained. Okay, it essentially obeys, etc. As I have already explained yesterday. For dilute solution like steel, steel is a dilute solution. Okay, so iron is the major and minor is carbon, silicon, manganese, phosphorus, sulfur, oxygen. Okay, and for special steels, alloy steels, chromium, nickel, and others. Okay, host of others. Okay, so like steel, like steel with moles concentration of solute, with small concentration of solute, or when atomic weight of A and atomic weight of B are comparable, are close, e.g. say I tell you iron, manganese. What is the atomic weight of iron? 56. Manganese is how much? 55. Iron, nickel, 56. This is 59. 59. Also chromium, iron chromium is 52. Like this, okay? Close, very. If it is very close, then what? First of all, there are two things actually here. Achha, let me complete this. Are close equation, which equation? Equation what? I give a, have I removed? No, I have not removed yet. This is written here, but still it is here also. So what it will be? Will be equation 12 will be approximated as HB weight percent, approximate weight percent B. Very simple. HB is weight percent. We call this equation 13. Call this last 13. This will be very important and useful. Very important and useful. In steel making problems we will take up later. We will see. We'll use these rather than this. We'll use these rather than this. What I explained, what I have said, follow me. I have said if it is dilute solution, which steel is or other alloys, okay, possible, okay, when we, with dilute solute, low concentration of the solute. So steel is actually very good example, okay, ideal example. So or when atomic weight or alternate condition first follow. If atomic weight of A and atomic weight of B close, like 56, 55. So close means say close. If it is close, follow this here. Please follow here. If this is close, see how it is 1. It becomes 1 so that HB weight percent is weight percent B. How it is 1? Say these two atomic weight are same. So what you have say call it actually say atomic weight of A is atomic weight of B. Shall I show it here? Atomic weight of A is atomic weight of B. So I am showing this part. this here, yeah, follow this. Just rough. 99 atomic weight of B, atomic weight of A. I'm writing this. Atomic weight of A, weight percent B plus atomic weight of A, weight percent A, weight percent B, atomic weight of B, weight percent A. Sorry. Okay, this is when atomic weight of A is close to atomic weight of B. Close. Then with approximation. This is what becomes top is what 100 atomic weight B. In terms of atomic weight of B, both numerator denominator, atomic weight of B, and this is what atomic weight of B, atomic weight of B common, what remains weight percent B plus weight percent A. What is this value? Weight percent in a binary, weight percent B plus weight percent A, how much it is? 100. This 100 cancel. This atomic weight B cancel, becomes 1. So this becomes 1. This is one justification. He might argue that chromium is 52, but close. This is one. See, these are transition elements. And these metals are actually in the transition elements, scandium to zinc, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, etc. But there are some exceptions. So iron carbon, far away from 56, 12. Carbon is 12, iron 56. Then you go to this. This is the precise relation. This is approximation. But for steel making problems, okay, when it is a carbon, then we'll go for this, okay. This is, you remember, or silicon. Silicon is how much? 28. And the iron is 56. So careful about this point, okay. Or what another reason I said dilute solution. Dilute solution means, suppose I tell you, suppose 1 weight percent. Dilute solution say 1 weight percent itself. If it is 1 weight percent B, it becomes atomic weight of A, and 1 weight percent which is 99 atomic weight of B means the numerator, denominator say for 1 weight percent B. Again, 1 weight percent B means atomic weight of A, denominator, plus 99 atomic weight of B, and top is also atomic weight of A plus 99 atomic weight of B. So they cancel 1. So dilute solution like 1 weight percent, or its neighborhood. Will not be exactly 1, but close. So both reasons. For dilute solution, one reason, another is when are close. Atomic weight of A and atomic weight of B are comparable, close. Okay. So you have reached, so I am removing this unnecessary now. So this is over. So this is very important, very useful, and actually in steel making we will use this often. So this approximation I have written here. I have written here. The rigorous relation 12 here, right here. Rigorous. For approximation, this is 1. This factor is 1. So 3 equations, you have got alternative equation for Henry's law. Next, let us take up. What shall you consider this? Okay. Now for dilute solution, okay. Now actually let's move to the top. Actually, only let us remove all these things. Okay. We have removed this. Remove this. This is activity. Maintain this. Okay. We don't like this anymore. Stop all this. You cannot handle so many things. Okay. So remove. Start fresh with something else related to Henrian 1 weight percent standard state and Henrian 1 mole fraction standard state. Next job. next job, and I will actually put you in the track. Good. So next, I have saved this. This one I have saved. Well, sometimes I'll refer to this. Okay. Next, what next, sir? Next is relation between HBMF and HB weight percent. Two Henrian standard set activities, HB Henrian activities in terms of mole fraction and in terms of weight percent. What is the relation? See, I'll give you. I'll show you here actually. See, this equation 3 was equation 11 was here. I should have mentioned this. Equation 11 was what? Here. Acha. I tell you what. Equation 11. See, follow here. 3 again. 3 coming. Again 3 between 3 different activities. Raoultian, Henrian mole fraction, Henrian standard. These 3 will be discussed all the time. So AB and HB. What's the relation AB and HB? AB is gamma B0 HB mole fraction. HB mole fraction. I'm sorry. HB mole fraction. AB is gamma B0 HB mole fraction. This is equation 3 already. Then another is this is between AB and HB. What is the relation between AB and HB? Means if I know HBMF, I will find AB. If I know AB, I will find HBMF. You can clearly see how important is this. Suppose I ask you, what is the HBMF at this point? At this, that is HMF point. AB is how much? Or I'm sorry, HBMF is how much? This scale. HBMF is what? So you apply this relation. What is the AB at this point? AB, the equation was gamma B0. The line equation of the line is activity of B is gamma B0 XB, and this is XB is 1. So activity of B is gamma B0 here, and that I showed last day, gamma B0 on this scale. AB all this side, all AB is this side, gamma B0. So if you know here, see the application. If you know at this point HMF, AB is gamma B0. What is HBMF itself? Gamma B0, gamma B0 cancel. HBMF is 1. I see I have put 1. You know one, you know the other. This is the beauty of this two activity relationship. Similarly, how you got this value last day? Discuss this. Go once again. What is the HBMF at this state? And you ask what is the AB at this state? You know pure state. Raoultian, R is Raoultian standard state, pure state 1. So when AB is 1, what is HBMF? Answer is 1 by gamma B0. See, I have shown. And this 1 here corresponding 1 by gamma B0. Follow. Gamma B0 here corresponding 1. Henrian scale. Like 0 and 0. Same. Okay. Now similarly, you want to get this. So AB, this is equation 11 already done. Now we are going to get this 15, equation 15 to develop what is this relationship HBMF and HB8%. See, this is last one. 15 we'll try to find. Okay, then we know one, we know the other. Very important. Okay. Suppose I tell you HBMF is 4 at a given state of B. At any point or at any state of B, HBMF is 4. What is AB? Raoultian activity. Your answer will be 4 gamma B0. This is the answer. And gamma B0, if it is given the substitute. Follow this. Okay, good, very good. Similarly, AB, HB8%, and I've finished this. HB mole fraction. So quickly take up this. From equation 4, from equation 4, From equation 4, what is this equation 4? See, I have said this very easy. HBMF is HP. From equation 4, we have HBMF is HP. Happy is HP, and is immediately converting into 8% is what? Tell me. It's standard. Atomic weight of A, weight percent B by atomic weight of A, weight percent B plus atomic weight of B, weight percent A, weight percent A. Okay. Therefore, we have this. We have this quality equation 14. We actually had last equation was 13. You see, check this. That HBO. This was 13. See, this is 13. This is 12. HBO percent is what is 13? 12. Right. What is 13 then? Oh, what is the 13? 13 is here. HB. I have removed this HB. This equation. HB approximation of this. Approximation of this. When it is 1 approximately, then HB 8% is 8% B is the 13. Equation 13 in the note. See, in your note you will get this. This is the 14 then. This is 14. Good. We have already this. This is 14. And then now by 14 divided by what? 12. By 12. By 12. What is the 12? What is the 12? Here this is the 12. This is the 12. Okay. If you divide by, see, you divide this. Divide this. This, divide this. What you will get? Follow. Left hand side HBMF. Left hand side 12. HB 8%. So write this. HBMF divided by HB 8%. Okay. Happy. Very good. HBMF is HB 8% divided by this. Left hand side by left hand side. Then this you have, and there you have this. So we write that out here. This is first. This is the numerator. So atomic weight percent B by atomic weight of A, weight percent B plus atomic weight of B, weight percent A. Right hand side, this divided by what is the here? You write atomic weight of A plus 99 atomic weight of B divided by atomic weight of A, weight percent B plus atomic weight of B, weight percent A. What else? Right hand side, this is whole you have written. Here what is even weight percent B, and still it is still there. Weight, then you write here weight percent B. See here, weight percent B. Very easy, you can do yourself. Very easy, so easy. So this is this denominator and this denominator cancel out. Cancel out. What remains? Right? Atomic weight of what a bit. What sorry? Why? Atomic. Oh, wait a bit. I made a mistake here. Oh, weight percent B where? Here. Not here. Weight percent B was here. This one. This atomic weight plus atomic weight of A plus 99 atomic weight of B divided by this times weight percent B. Sorry. Times weight percent B. And happy that cancel. So what remains? Very easy. Atomic weight of A divided by atomic weight of A plus 99 atomic weight of B. Right here once more, HB mole fraction divided by HB weight percent. Subscript. Box this, very important. This actually I have written here. I have written here. Call this equation 14. Call this equation 40. What is this? Okay. No, you write this rather, or you write this is better. I'm not giving the name of this, or write this way. Hb mole fraction is atomic weight of A by atomic weight of A plus 99 atomic weight of B. This is a factor times Hb weight percent. Rather, instead of this, you may highlight this one also similar, same, but it may be better. Call this equation. What equation? Equation number. As I told you, this will be 15. This is the 14. 14 you got 14. 15 is here. 15 is here. See 15 saved. So we have actually again activity relationship. 3 activity relationship, and we have enlisted them here. So this is the next job actually. So 15. So you write here again. So write here again. Write this. So let us list the relations between the three activities, namely Raoultian activity, then what you call it, Henrian mole fraction, and Henrian weight percent, standard states. Standard states. I tell you, Raoultian, what I said, Raoultian activity means activity with respect to Raoultian standard state. Symbol AB. Henrian mole fraction activity means activity relative to Henrian mole fraction, 1 mole fraction activity. Henrian 1 mole fraction standard state. Symbol HBMF. And last is activity, okay, Henrian 1 weight percent. Henrian weight percent activity means activity relative to, with respect to Henrian 1 weight percent standard state. Symbol HB weight percent. So we list the relation. What is the relation? These relations are relation between the 3 activities: Raoultian, Henrian mole fraction, and Henrian weight percent. 3 equation numbers is also written here: 3, 11, and 50. So you can get this. Okay, see my point? So as a result of which you can see one thing important. See here, you take up. So you have a new scale, HB weight percent. You want to find the HB weight percent when you know the AB. What is the relation? AB and HB weight percent. This is the relation. So follow me. When AB is when HB weight percent is 1. When HB weight percent is 1, which one is HB weight percent 1? You see, tell me, what is HB weight percent 1? HB weight percent For which one? 1 weight percent B is what? Henrian activity, Henrian standard state, activity of Henrian standard state with respect to Henrian standard state. I'm sorry, activity of B at Henrian 1 weight percent standard state with respect to Henrian 1 weight percent standard state. Same. That means 1. So this activity of a Raoultian standard state with respect to Raoultian naturally will be 1 like this. This Raoultian standard state with respect to Raoultian 1. Same reference. State under study and standard state are same. The ratio, activity ratio of two things. So this is 1. This is 1. If this is 1, which scale? Follow, it is not HBMF, it is HB8%, 1. HB8%, according to HB8%, what is the active HB8% value at H8%, means at this standard state, H8% point, at point H8% is 1. Okay, this is actually, because this is 1 standard state. And this is very good. If it is 1, then what is the AB? AB is what? If it is 1, what is the AB? Gamma B0 times atomic weight of A divided by atomic weight of A plus 99 atomic weight of B. This is AB. This is AB. AB means this scale. AB is this scale. Why do you get this? See, this point. What is the AB value? As a dotted here, and I have shown by this one. So this point is what value? What value? I have shown here. I don't have space there. I have written here. It is gamma B0 XB 1 weight percent is what? Exactly this one. Gamma B0 atomic weight of A divided by atomic weight of A plus 99 atomic weight. Because see, this is actually you can do it yourself, okay? Because gamma B0 XB, what is AB? Gamma B0 XB line, and XB is corresponding to 1 weight percent. This I did so there, and now you see this is saved here. So when this is known, this is HB8% is known, the AB is known. Okay. Now another thing is this. What is the relation between these two? HBMF. When HBMF is 1, what is HB8%? Tell me. What is HB8% when HBMF is 1? Correspond to this point. When this is 1, HBMF is 1, what is the value, corresponding value? HB8%. Apply the relation. So when it is 1, HB8% will be what? Atomic weight plus 90, A will be what? A plus 99 atomic weight B by atomic weight of A. This will be HB8%. Is at where? When HBMF is 1, when HBMF, this is 1, what is this value? This is the value. This is again, apply that approximation, that is atomic weight of A and atomic weight of B are comparable, then this is nothing but 100 atomic weight B on the top and atomic weight of B denominator. So cancellation 100. What I have shown there? Approximately. So from any to any, you can get this. Remember this, okay? So this is also you see another way. See, I told you that the Henrian here. Second, what is the value of AB when HB8% is 1? Which point? That H8%. The third standard state. Henrian weight percent standard state. The point H8%. What is the Henrian activity? Henrian weight percent activity. What value? Since this point is Henrian standard state, and I am asking about Henrian weight percent standard state. I am asking with reference to Henrian weight percent standard state, it will be 1. Mathematically see here you have HB weight percent, follow. When weight percent B is, this is the relation between HB weight percent and weight percent B. When weight percent B is 1, follow, 1 is 1. And you can denominator follow 1 and 99. So 9 atomic weight of A plus 99 atomic weight of B, and top is also atomic weight of A plus 99 atomic weight of B. Cancel leaving weight percent B, which is 1. So HB weight percent is 1 at 1 weight percent B, as it should be. At Henrian standard state, generally speaking, at Henrian standard state, Henrian activity is 1. Or specifically at Henrian weight percent standard state, Henrian weight percent standard state activity, Henrian weight percent standard state activity, or simply Henrian weight percent activity is like Raoultian activity. At Raoultian standard state means these are what is Raoultian activity? The same 1 as it should be. Okay, so this is it. And here also you can see here also this is the Henrian mole fraction. This is the standard state. Henrian mole fraction standard state at this point. And what is this Henrian mole fraction activity? See, 1. This scale. Remember 3 scales running AB parallel ordinates. This is AB scale. Don't confuse. All values I have written here, gamma B0, AB value. And now I have written here this one, AB value, AB. Okay? And this scale is HBMM. And still another scale, HB weight percent. So I think I have stopped enough. So this is very important. So no problem. So you have to solve some assignment problems, and you will see this. Now next, consider. So this is over. So this list the relationship I've listed here. Okay. So this part is for next. Now consider quickly point P. I'm removing this. Okay. Now consider point P. A different thing coming. Activity coefficients are coming. Now this part is over. Now take up activity coefficient when the state under static deviates from the laws, corresponding laws, respective laws. So from Raoultian line, it deviates, so you have to introduce activity coefficient called Raoultian activity coefficient. If it deviates from Henry's law, Henrian activity coefficient. And since there are two types of standard states, so we have two different activity coefficients. You follow me. Now consider P. Last day actually I have already shown. I have shown that what I have shown last. What is HBMM? Equation 8. Remember what is Henrian mole fraction activity coefficient. What is that? I showed in the binary system gamma B by gamma B0. This I showed. Today also I will show something. Okay. Now I am starting here. AB weight percent. Then you correlate these two. Now consider point P. P. Just any arbitrary point. Point P. On the deviation here. It is deviated from Raoult's law. And not only Raoult's, also from the Henry's law. Henry's law is this. Deviate. It is neither on the Henry's law nor on the Raoult's law. So deviating from both. And in both cases, you have to introduce activity coefficient. This is a job. And find the relationship of the activity coefficients, corresponding activity coefficients or two different activity coefficients. Do this. Consider point P. Now consider point P as before. Which does not lie either on line OMR. What is that? OMR is Raoult's law line. Raoult's law line. As you see, OMR, Raoult's law line, okay, and or what? OH weight% NHMF, this line, okay, or this is called Henry's law line. Doesn't fall on this case. That is at the state given by point P, at the state given by point P, this state, at the state given by point P, the activity of B in the solution shows, activity of B in the solution shows shows deviation. In the solution means what? In the solution, in the AB solution, AB binary solution. In the solution, AB, okay, binary alloy, but sometimes binary mixture you may call. Binary solution, in the solution is binary solution, shows deviation from both Raoult's law and Henry's law. Hence, at P, we have what? Follow quickly. Again, I've already said once, this point is neither on this line nor on this line. So deviation from Henry's law, deviation from Raoult's law, both. In this case, we have to introduce activity coefficients in either case, and we'll try to find the relation between the activity coefficients. Let us start. Hence, at P, what I write? I'm writing AB is what? AB is what? P. What is AB? AB is not XB, not Raoult's law. It's already written here. Gamma B XB. You know very well. AB is gamma B XB. This you know very well. AB is gamma B XB, and you convert into weight percent. XB into weight percent. No, you have standard here. XB into weight percent. Atomic weight of A, weight percent B, divided by atomic weight of A, weight percent B, plus atomic weight of B, weight percent A. You happy? Gamma B into XB. Okay. This is the AB. Gamma B is introduced. Gamma B we have introduced. Gamma B is what? Write this out. Gamma B is, write nicely. Gamma B is Raoultian activity coefficient. Happy? Raoultian activity coefficient, very good. And HB, HB weight percent, tell me similarly. HB weight percent. What is the equation of the line? Line 12. HB weight percent, and this exactly. This is approximation. Approximately weight percentage, but exactly this one. So if it falls on the line, if the state P were on the line, but it is not. It is where? Here. So what you have to do? This is as if ideally, this is ideal, means ideally true, means when the state falls on the additional line, this equation will represent that point, will describe that state, that point. Now since it is outside this, deviates from this, so we have to introduce on this suitable activity coefficient, right activity coefficient, corresponding activity coefficient, namely Henrian weight percent activity coefficient. And that last day you got the symbol Henrian mole fraction activity coefficient, ABMF, ABMF, last day. So similarly it should be what? HB, AB weight percent. And the rest is same, rest you introduce, rest is same. Rest is same, rest is same. Yeah, equation, right? Atomic weight of A plus 99 atomic weight of B over atomic weight of A weight percent B plus atomic weight of B weight percent A, happy? Sorry. Up to this point, then weight percent B. Then weight percent B. This will be the equation. This equation will represent this point P. This equation will represent this point. Have I given any equation number? Let me check. Let me check. Okay, I have given it 16 here. So we have gone up to 15, 16 here. Which one 16? Tell me. Call it 16. Equation number 16. 16. Clearly 16. 16. 16, and what is this equation now? 17. 17. Call this equation 17. 17. Okay. 16 and 17. Now go to the top. Now go to the top. Go to the top. These are all there. Remove this. Remove this. This also over. Relation between HBMF. These are all over. Careful here. Careful here. Acha, since let us see how much we can manage. Again here, this should not be removed. Activity. Raoultian activity. So from this point, we take up here. We take up here. Take up here. Okay, what is this? But we know we already have. We already have what? We already have AB is what is, let me write. AB is gamma B0. AB is gamma B0 atomic weight of A by atomic weight of plus 99 atomic weight of B atomic 99B HB weight percent. This is already equation already given to this HB 11 already. And where it is, where it can be, the relation between two activities AB and HB weight percent. Here activity relations here. This is the Henry's law equation in different forms. What is this? activity acid. See, this equation number 11. I have already written 11 again. See, AB is gamma B0, etc., and exactly HB8%. You already have. So from this, what you will do? You can write this, okay? Or you write this, or from this and this, I will substitute this one. What I will substitute here? Here into this value of HB8%, into this value of into this here this value of HB8%. Let me do this from what and what, from 17 and 11. So 11 what you have, right? So this may be lengthy. We just start here. AB, just when you come here, I will write this. AB is gamma B0 times atomic weight of A over atomic weight of A plus 99 atomic weight of B. Happy? And just see, copying only, copying. Many places actually. And instead of HB8% in terms of activity coefficient, so HB8%, if you follow later, you see there's a system. I'm following certain system. See, HB8% times, tell me, atomic weight of 1 hour 58 minutes to 2 hours. So, 2 at 8 minutes it will be over. Plus write this 99 atomic weight B. Happy? Right underneath atomic weight of A atomic weight of A, weight percent B plus atomic weight B, weight percent A, this here times weight percent B. This we get combining this and this and this, substituting this value into this, we get this. And we have another equation already. What is this equation? This is okay, and this is already, this is the one, another one already. Let us see, we'll do this, but let me simplify this. Simplify, what simplification? So this cancel. This cancel. So let me write then, whatever remains, gamma B0, atomic weight of A. Actually, FB0, whatsoever you write? Okay. Atomic weight of A, weight percent B. Follow. Atomic weight of A, weight percent B. I'm writing this letter. Divided by this one, whole one. Atomic weight of A, weight percent B plus atomic weight B, weight percent A. See this one. Then what remains? Times FB weight percent. Okay. This FB weight percent. Let us give a name to this equation. Last equation, what is this? 17. This must be 18. Okay. This must be 18. 10, 5, 18. So this is 18, and what you have here, what is the name of this equation? 16. From 16 and 18. Comparing 16 and 18. Can I remove this? Easily. Comparing 18 and now and 16 before, 16 here, 16 What you see? This is left hand side is AB, right hand side is also AB. I am very sorry. Very sorry. Left hand side of this equation 18 is AB and left hand side of equation 16 is also AB, same. So right hand side must be same. So let me equate this, or you write this, or write this, or gamma B. Write this. Right hand side of this, write nicely. Gamma B, what do you get this right hand side? Gamma B, atomic weight of A, weight percent B, divided by atomic weight of A, weight percent B, plus atomic weight of B, weight percent A. The right hand side I am writing, right hand side writing of what? 16. This is 16, equation 16. 16. Right hand side I have written, totally complete right hand side. And this right hand side also is right here, right here, is gamma B0, right hand side of 18. Atomic weight, you give a bracket maybe, atomic weight of A, weight percent B, by atomic weight of A, weight percent B, plus atomic weight of B. See here, weight percent A, give a bracket, and what remains? AB weight percent. AB weight percent, and then if to this you get, then this whole thing cancel out. What you get then? Or AB weight percent is what? You resolve this. What is AB weight percent? Is gamma B by gamma B0. Call it equation 19. 18, last class 18. So this is 19. Equation 19. Okay? Equation 19. We already have last equation, equation 8 I remember. Equation 8, yes. Last equation, very last equation. We already have AB mole fraction. AB mole fraction is what? Gamma B, same. Exactly the same, equation 8. Oh, 8. 8. Last class, 8. Very good. Hence, what you see? Hence, you write, can you remove this line? Hence, what you write? AB mole fraction is same as AB weight percent. Henrian activity coefficient, both are same. Both are required. Okay, so AB mole fraction is they are required. The two Henrian activity coefficient. I told you here somewhere. Didn't I mention? I mentioned perhaps sure. AB mole fraction. What is AB weight percent? Did I forget to write this? AB yes, AB weight percent. Yes, I forgot. Acha, I am writing here. I wrote first where? I wrote here perhaps. Yeah. Yes, I got this. Here I forgot to mention what is AB weight percent. Gamma B is Raoultian activity coefficient. Fortunately, this line is still actually intact. So I am writing here. Please note this here. Then you give it star. It goes there. Okay. Here you write what is AB. Like gamma B is Raoultian activity coefficient. Okay. AB weight percent is what? Tell me. AB weight percent is Henrian weight percent activity coefficient, to be specific, Henrian, clearly, Henrian mole fraction activity coefficient. Sorry, I forgot to write. Please write here, along this, okay? Here. After this, I introduce this here. Where I introduce H will see here. Since when it is on Henry's line, this is the equation. If it deviates, introduce activity coefficient. Namely, here suitable one is Henrian activity coefficient and weight percent. Henrian weight percent activity coefficient symbol is FB weight percent, and this is introduced. So this multiplied by this factor. So this I have written, and this is the explanation. Like this, gamma B is what and FB weight percent is what. So FB mole fraction is gamma B by gamma B0. So both are same, and both are equal, and they are each equal to gamma B by gamma B0. Gamma B here, this is gamma B. Gamma B0, gamma B at 0 concentration of solute, or XB is 0. So this is yours. Finally, 19 and 20. Equation 20, with equation 20 we'll stop today. Then I have little bit left that I will cover next class. Particularly I will consider ternary. If it is ternary system instead of binary or any other multi-component, what will happen to this relationship? Because this is actually sometimes complicated in some books, okay, and textbooks, etc. So I want to clarify what will happen if it is ternary or any other multi-component. For binary, but this is clear. Both are exactly same. Both are identical. Both are exactly the same. And value is what? Gamma B by gamma B0. Gamma B is Raoultian activity coefficient B generally, and gamma B0 the special value. The gamma B at XB is 0. That is gamma B0. This you know very well. So thank you very much. With this, we have actually completed our discussion and lecture. And see you in the next class. Thank you for your cooperation and for your attention and interest. So see you next class. So let us call it a day now. Bye.